One of the things that has happened in astronomy in the last 20 years is that our technology has advanced to the point where now we are starting to find objects outside of our solar system. And one of the most interesting fields of study is looking for planets outside our solar system. These are what are referred to as exoplanets or extrasolar planets. And these are essentially a planet that is going around a star other than our own. And what we really want to know is we want to find out the ultimate answer to the question is, are we alone in the universe? Or is there life out there somewhere? And finding an exoplanet or finding exoplanets and then narrowing it down to ones that are most likely to have life is a huge field of study in astronomy today. Most exoplanets are like Jupiter, huge gas planets. And actually, most of them are much larger than Jupiter, several times larger. And the reason why is that they're easier to find because they're bigger. They have greater effect. And what happens in this case is that stars are so bright. They're millions of times brighter than their planet that's going around them. And so it's really difficult to see them. And so we need these big ones to find them. The first one was discovered in 1992, over 20 years ago. And since then, that number has slowly crept upward and then recently gone up exponentially. Now there are over 1,700 confirmed exoplanets outside our solar system. This is the direct result of the Kepler spacecraft, which was launched just to locate exoplanets that are nearby us within less than 100 light years away. The Kepler is no longer functioning. It did function for 2 years and found a tremendous number of them. Most of these exoplanets have never been seen. Because of that bright light of their star, we can't see them. It's like black holes. We don't see them. We see what they do to space around them. And with exoplanets, what we see is what they do to the star. Do they cause the star to slightly move as the planet's gravity pulls on it as it orbits? Do they cause a Doppler shift in that star's light? Do they decrease the amount of light as the star passes in between it? The first pictures ever taken of an exoplanet are shown in this image right here. So what they did was they used what's called a coronagraph. So what they do in this case is they block out the light of the star here, and they do this so that even these faint objects can be seen. And you can see in this box right here that there is a very faint object right there, and that is the exoplanet. And they took two separate images 2 years apart to show that, yes, indeed, it was moving. And here we did have this object that was orbiting another star. And since then, the number has gone up slightly. And in 2014, they completed building a telescope, which its singular job on this planet is to take images, actual images of other exoplanets. So again, here we have a star which has been blocked out in a coronagraph image. And then you can actually see that we have 3 exoplanets orbiting this star. Now, how do we usually locate them? The way that we usually locate them is the transit method. And this is essentially blocking out light as an exoplanet, an object here, passes between the star that it's orbiting and us. The amount of light emitted by that star will decrease slightly. And if they measure that happening on a reoccurring basis over the course of 3 years, they confirm that there is an exoplanet there. So these are amazing advances in technology that are allowing us to see these tiny objects light years away from us, trillions and trillions of miles.